Hello, everyone. On this episode of the Better Product Solutions podcast, I bring you Phil Heft, Business Development Manager, North America from Memcon, and a topic that connector assemblies. Phil goes into the purpose and functionality of connector systems in printed electronics. We talk about market trends, what's driving connectors and the different styles of connectors, as well as going into design specification considerations for someone designing a printed electronics circuit design and some things that they should understand as far as the connector part of that design. So I bring you Phil Heft. Thanks, everyone. Hello, everyone. Welcome to the most recent episode of the Better Product Solutions podcast, and excited to bring Phil Heft in here. Phil's title officially, Business Development Manager, North America, Memcon, and we're going to talk some connectors. And Phil, I'm really happy to have you on because as I've gotten to know you, I'm realizing how long you've been in the industry and the perspective that you bring. So I'm excited for that to come out during the conversation. And so thanks for being on, Phil. And
terrific.
Yeah, sure. The first question, I guess, is the softball, but tell us about yourself, your role, Memcon. Some people may not be familiar with Memcon, so if you could give the official intro, much appreciated.
Terrific. Yeah, it'd be my pleasure. I have been selling for printed electronics membrane switch technology for half my career. I was a manufacturer's rep. And in the latter part of my career, I started selling to the membrane switch industry. In the past 6 years, I've landed a position for Memcon. Memcon is a international company that is focused totally towards printed and flex electronics. They have tooled and manufactured various components for the manufacture of printed electronics. There's a lot of expertise in our company. Our locations in Europe, North America, and in Asia are filled with people that have been doing this for their careers. So we have, as I said, that expertise. We've built products that are fresh and low cost, and we are doing our best to make the industry as strong as we possibly can.
Yeah, I mean, you're 6 years at Memcon, but obviously not 6 years in the industry. So you bring like a historical perspective of kind of where we were and I'd say where we are now. So how would you frame up, I guess, where this printed flex industry has been in the past and kind of how we've evolved to where we are today?
When I first started selling membrane switches back in the early 1980s, the industry was really in its infancy. It was a sort of a sibling child of the flex printed circuit industries, the FPC industries, and they were working with different types of materials and different constraints. And one of the biggest changes that I've seen has been on the time of manufacturing. Back when we started in the 1980s, it was typical of 10 to 12 weeks just for initial prototype tooling. In today's market, you are producing your second production order in 12 weeks. Things like that have been important. Tactile domes, back then, a lot of poly domes were used in the industry. Metal domes were in their infancy, and today's metal domes are much better than they were back in that time as well. So the product has improved. Polycarbonate materials, which was a mainstay of membrane switches, is now almost a no-no. So the evolution of the products, the sophistication of manufacturing, the product mix, your customer base, and then we go into the evolution of what printed electronics is today. I mean, everything from photovoltaic products to medical sensors. It is just a completely different world, and it's a very exciting world to be in.
And they all need to connect at some point, right? Because it's funny, as we were preparing for this, I've had a chance. I've never really paid this much attention to the connector part of this whole world. So it's interesting when you talk about these connector systems. I guess at a high level, what's the purpose of a connector system? And what purpose does it serve in the overall kind of flexible printed electronics in the grand scheme of the product itself?
Well, it's an interface product. I mean, essentially, we need a way to go from a printed, flat, flexible piece of product to a board of some type, and it can be done either as a direct mating into a PC board, or it could be a interface cable going into round wire. Something has to be done. So the traditional flexible printed circuit board connectors were the easy way for printed electronics to get involved. So flexible printed circuit board connectors had a few mainstay products. They were, of course, crimping into copper products, and they were sort of coming into it either through the pad on the circuit board, or they were going around the pad and coming back on reentry. Those technologies married very well into printed electronics. And though there are some critical differences, it is just enough that you can make it work. The biggest issue was the thickness. The thickness of flexible printed circuit boards was a 1 ounce copper, which is about 1.4 mil. And you had to duplicate that with printed ink. And that was not always easy. So the connector technology had to improve. So that's the basis of where the connectors started. And the technology has just improved from that.
And there's been different connector systems, right? I mean, there's a whole variety of different connector systems that are used in different markets and applications. But can you speak to a little bit about the markets and applications that are applying where the use of these types of connector systems are, I'll say, either most used or on the rise, or what trends are happening where these connectors are getting more and more use and or being phased out or replaced?
Well, the biggest change that is happening in the industry is as the membrane switches have become more sophisticated, the number of traces that occur have increased. So the oldest technologies and still the most popular technologies on connectors is at 100 thousandths or 2.54 millimeter pitch spacing between the conductors. Well, that's fine when you have 5, 6, 10 conductors because you're less than an inch of width of real estate. But the problem comes when you have a lot of embedded components, and we're now at 25, 30, 35. So we're now talking about a real estate problem of 3.5 inches when people are trying to shrink things. So what has happened as the trend lines is, one is to go from 100 thousandths on a crimp connector system to 50 thousandths on a crimp system at 1.27 millimeter. So that's one trend line. The other one, of course, is trying to marry against flexible printed circuit boards, which will also use ZIF and lift connectors. And ZIF and lift connectors are wonderful on one level because they only have the tail embedded into the connector on the board. But there is a problem and a challenge for the industry because of placing that tail into that connector could become challenging. Edge registration, things along that line. There's also a limitation to how thin you can print your trace lines onto the pad. So those are part of the changes in the industry, going to more and more traces and thinner lines.
So I grabbed one of our engineers and I got kind of like the tour of one of our manufacturing areas, and I was looking at all the different type of connector systems. So I saw the traces on the areas where we had to crimp, just getting narrower and narrower, it seems, on how to fit in there. So I definitely hear that on someone who's actually looking to design or who's on the design side of the house, someone who's designing a flexible circuit or wants to transfer from a rigid circuit board into a flexible circuit, or wants to learn more about how to specify the right proper connector solution. What are some of the things that they need to think about in terms of attributes of the end product that would be a consideration for the selection of a connector? Like you obviously mentioned the ZIF connector, which has a completely different pull pull standard specifications in terms of robustness. Can you speak to, I guess, some of those considerations of strengths and weaknesses of the different types of connectors and what it would mean to the end product application?
Yeah, the most robust connector systems, the ones that will take the highest pull force test of the product, are crimp style. Crimp will take up to 10, 12 pounds of pull horizontally per contact on your circuitry. When it comes to a ZIF, though, you can just inadvertently pull the connector right out of that ZIF connector, scratch it, tear it, all that portions of it. So if you're looking at an enclosed system where people will not be doing a repair and it's very, very fine line, you can get away with a ZIF connector. But if you're dealing with something where it's an interface product and there may be in a medical situation where it might even be a disposable, you need a product that will mate properly, give you the proper electrical characteristics in it, and yet be able to be removed from its product without too much strategy. So in the case of Memcon and some of our competitors, there are several different systems you can go with. And the most traditional system is basically a friction type situation where you have a female connector mated to a pin header where just the contact springs will be hugging onto the male pin, and that's the entire insertion extraction force. It is better than nothing, but you can inadvertently pull that off of a pin header pretty quickly. The other alternatives are to go to features that will give you some retention. There's one called the Detent System, which is basically a bump on the housing, which will interact with a header with a hole in it so that it gives you some retention. It's not a lock, but it will give you a firm retention. The next strategy would be go to a latching, and latching is probably the second biggest market for us because people do like to have that positive click of engagement and know that you can't remove it without depressing the latch and then removing it that way. That works really well in many situations, including a lot of the medical devices we were talking about prior. The last one is more of a locking system, and the locking system comes from a European standard that has a locking mechanism that mates to a profiled header so that the only way you can remove it is by spreading the walls of the header that it's mating to. That is not popular in the States, but you will see a fair amount of it in the European markets.
And all of these systems require, assembly equipment. So, I mean, there's obviously all these implications in the hardware itself that's actually, connecting, locking, and all the choices that can be made to either have that freeform pull out or if someone wants it to actually snap lock. But in terms of the equipment support, I mean, Memcon supports this with an assembly type system that helps the manufacturer assemble all these things, right?
True. And this has to do with the strategy of our assembly equipment. Memcon's products are all done with what they call mass termination of the contacts onto the part. There is a different strategy out there with competing processes which stitches on the contact one at a time, much like a sewing machine. We found that system, one, is slow, and two, it has a tendency to put stress into your circuitry to curl it. So the mass termination speeds up the assembly process and also keeps your material flat. So Memcon promotes several different connectors, but the one we're really very excited about is our two-part system. So essentially, you use the same female contact, and you can engage the plastic to do any of the features that we previously talked about. So I can give you a standard housing, a latching housing, a locking housing, anything you want off the same base female contacts. So that's really the system. It speeds up the operation. Typically on a crimp contact, depending on your operator's skill level, will be somewhere between 200 crimps to 600 crimps an hour on the crimping, and putting on the housings will be on the similar 300 to 600. So your yield of assembly is pretty significantly higher with our system.
And that yield is tested with usually 100% test inspection at the end of of circuit performance, right? And so at the end, generally speaking, there'd be a test perform on each circuit to verify that it's functioning properly.
It's not necessary. They're basically a visual inspection. We usually recommend an AQL level or a respected level of testing of about 3%. But your operator should be able to see the contacts folding over on the other side. And if they see the contacts per our specification, they would be nearly perfect that way. Certainly, if you get into some of the military environments, you will have to go a higher AQL level because they want it that high. But certainly from a performance level, we don't see any reason to go beyond 3%.
Mm-hmm. You mentioned medical. Are there any other markets that you're kind of excited about in terms of seeing growth in the use of the type of the hardware that Memcon's selling and these interconnect solutions?
Well, certainly sensors are a big portion of it. Force sensors, FCRs, are becoming a huge market for us. We go forward. I always get excited about the emerging technologies, and among the things that we see are the printable solar cells, which is, it's who knows where that's going to go, but we've been sampling and working with different companies on that. They've been playing with printable batteries forever. Maybe one day they'll actually get them to work in a cost-effective way. But these emerging technologies that have been around and are starting to come about are always exciting. The traditional human-machine interface, the HMIs, will always be a big part of what we do. I do think that they've changed a lot with touchscreen technology, of course. But we're as I said, on an explosion level of products. They've been talking about in-mold electronics and in-mold decorating for a while. They've been talking about RFID products in printed situations. All of these hits, and the world has changed for your industry or our industry together.
Yeah, and it seems like on a lot of these podcasts, whenever we're talking about printed electronics, it's always a common theme of getting thinner, smaller, lighter, and everyone's just really trying to condense the package down. And so when you're talking about, spacing getting tighter and all these things, and it's just such a trend. I mean, everyone's just trying to get tighter, more compact, flexible, curving around surfaces, yeah, it goes on and on.
Yeah, and at the same time, your challenge and our challenge as a supplier is to keep the cost down. I mean, the reality is that this only works if people can afford to pay for it or want to pay for it.
And of course, when we're recording this podcast, there's a lot of supply chain shortages around the world, and is that something that those been challenges that you've been dealing with?
Initially, we had when COVID hit. A lot of our product was being used in the ventilator products, and we had a huge demand for it that drew on all of our inventory and put a challenge into the supply lines. It took us some months to get out of it, but once it did, our manufacturing process has been fine. We haven't had any issues at all. We've had logistics issues. I won't lie to you about that. I think the world has been dealing with the problems. The big thing, we have 3 stocking locations, one in Europe, one in Michigan for North America, and one in Hong Kong for Asia. And we move a lot of product between those facilities to facilitate any demand that we might have and get things done quickly. So it's been a challenge. I give our ownership a lot of credit for keeping going. I haven't had to deal with too many issues here, so I've been pretty excited about that.
Yeah, good. Thanks for sharing. Yeah. That's all I had, Phil. I mean, I think oftentimes we've been doing we've done podcasts on different membrane switch topics, but the connector it's kind of like, doesn't get a lot of, praise or a lot of attention in the spotlight, but obviously really critical for things to work in the end. And obviously from a durability standpoint, or if something gets broken, you want to quickly replace it in the field, right? It's just a quick disconnect, replace, reconnect, right? So I appreciate all the sharing. Is there anything that you want to comment on, Phil, or I guess wrap up because we're kind of going to wrap it up?
Yeah, I thank you for the opportunity to talk to you guys. I've known TapeCon for my career, and You've been a good friend and a good partner for our industry, and I encourage all to understand that printed electronics is a vehicle for the market. I believe heartily in we promote the industry and everybody succeeds. We're really very much in that line.
Yep, absolutely. Well, you're a big contributor, Phil. I mean, it's amazing the amount of knowledge that you have in this category just talking to you. So I really appreciate you being on. So thanks for coming on the podcast, Phil. Thanks.
But be well, Stephen. Bye-bye.
Okay. The Better Products Podcast is about educating product teams about new materials and new technologies, all in the custom material converting and printed electronic space to help them design and build better products. So in this podcast, I'm hoping to get wide-ranging conversations with various people throughout the industry and just bring a lot of good content to the table. So if you're interested in learning more about the industry, materials, processes, how to improve products if you're on a product team, or just general know-how of what the heck is going on in this industry, then subscribe to the podcast and get ready for some more really good episodes as I bring in some great guests. Thanks.